Okay, so apparently we are recording. So we're going to talk about section 9.7. If you have a book, page 65, 655, exponential growth and decay. Okay, so we're going to work with a formula, and this is the continuous exponential growth formula. Continuous means that it, unlike compound formula that deals with monthly or daily, this is instantaneous. It's used for bacteria growth and different things like this. So this is the final amount that you're going to have at the end. This is the initial amount of maybe bacteria or population or whatever we're talking about. E is our constant, 2.71828, and K is the rate of growth, and T is the time. So we're going to use this. So let me go through this. So this is your final amount. Abbreviate. This is your initial, how much you started out with. E is a constant, 2.71828. K is the rate of growth or decay. And that has to be written as a decimal. If it's a percent, it's got to be changed to a decimal. And then finally, T is the time it takes. And that could be in days or years or whatever the problem depends on. So we're going to answer some questions here. In 2013, the population of Ghana, which is on the west coast of Africa, was about 25.2 million. And the exponential growth rate, in other words, it's growing every year at 2.19%. The population is increasing. So it says, find the exponential growth function. Okay, so we're going to start out with our formula. And we're just using this formula right up here. In our, I'm going to zoom in a little bit. Our exponential function on this particular one is going to be the original population is 25.2. So we're going to replace that with PO. PO means the original amount. O for original. 25.2, we won't run a million. E, of course, is a constant. The growth rate was 2.19%. So we want to change 2.19% to a decimal. We're going to move it over 2 places to the left. 0.0219. And I like to put these in the parentheses. And on this particular one, we're just going to leave time as T because we don't have the time right now. So we'll leave this as T. So that's basically our formula for this problem. So the next question is, what's going to be the population in 2018. Okay, so we're going to put this into this formulation. The population in 2018 will be equal to the initial population, which is right now 25.2. We're using this formula, 0.0219. But for time it has, we can't put in the 2018. The initial population was in 2013. So 2018 minus 2013 is 5 years. So we want to put the time in terms of years, times 5, like that. And this would give us a population of 2018. So it's just a matter of using your calculator. Try to find one. Go this out. So this is 25. Let's go this all out. 25.2 raised to parentheses point. Oh, wait a minute. We forgot E in here, didn't we? Oh, let's try this again. 25.2 times E. How do I get E? I'm going to hit second ln because I need E in here. E to this power. And you see it already has the parentheses, 0.0219. Got this cord coming around here. Maybe I'll put this over here. Then I'm going to be out of the way. 0.0219 times 5. When I hit the times key. Parentheses. Okay, here we go. And that should be the population. 28.116, or however they want to round it off. They round it off to the 10th place. And this would be million. So it's 25.2 E, second ln, raised to this power. And that'll give you the population as it's growing at 2.19% per year. So we have to change that to a decimal. Okay, the next question is, how long will it take the population to double? Okay, I'm going to jump ahead and show you a little trick. On page 660, this is the formula for doubling. The double formula, I'm going to abbreviate double, is T equals ln2 over K. T equals ln K over 2. You can do it the way the book does, but that's going to take a whole bunch of steps, you see. So instead of doing all these steps, going through this is kind of a shortcut way of doing it. So we're going to find ln2 on our calculator. ln2 parentheses divide by K. And what's K? In this case, K again has to be written as a decimal. 0.0219. Okay, so we're going to divide that. And enter, and this will give you the number of years. 31.65 or 31.7. Approximately 31.7 years. It will double. Population doubles. And according to the book, we came up with a higher number, huh? Let's see what they came up with. They came up with 50 years. Let's see. We're looking for the time for which 25.2 million is going to double. It's called a doubling time. No, they came up with 31.7. You see, but they had to do all this work. And they came up with 31.7. And if you notice in their formula, they ended up dividing ln2 by our number. So this is just a shortcut to find a doubling time. And it's one you should remember. We're going to use it some more in here. So we have two basic formulas. We have this formula, and then we have the doubling formula. Okay, it says when would the population of Ghana reach 40 million at this great growth rate? Okay, so what we're going to do is a little bit more complicated. Take our original formula, which is this one right here. And we want to know when is it going to reach how much? 40 million. We're going to use this formula right here. It's this one right here from problem 1. When's it going to reach 40 million? Well, we're going to put 40 here. It's 25.2 now. E to the 0.0219 t. So how are we going to solve this? Well, first of all, we're going to divide both sides by 25.2. Let me put a little piece of paper down here so we have more room to work. And let's turn this a little bit here. Okay. And we divide both sides by 25.2. So let's do that right away. The book does it slightly different, but so we're rounded off to 1.587. That should be pretty accurate. Equals e to the 0.0219 t. Now what I'm going to do is I'm going to take the natural log of both sides. And because we have a theorem, we have a little theorem that says if you take the natural log of e, you just get the exponent. It kind of undoes that. It's log base e of e will equal your exponent. So natural log of e cancels out and we get ln 1.587 equals 0.0219 t. So if I divide both sides by the 0.0219, I'm going to get my answer. So let's enter this in. ln 1.587 divided by, let me quote, now see, I don't want to do it this way. I need to close that parentheses because it won't work. Let me just close this out and do it again. ln, I'm thinking ahead in my brain and it's not working. I need the parentheses closed, then divide. If you don't do that, sometimes it won't come out correct. 0.0219. So this always has to be a decimal. Equals. And it should take about 21 years for the time. Now these answers are approximate, and it's depending if this growth rate stays the same. Growth rate could change. That's how we do D, a little bit more complicated. 40 divided by 25.2, get rid of the 25.2. Then we want to get rid of the E. Took the ln of both sides, natural log. Then finally we want to get rid of the 0.0219 to K. Okay, so let's try another one of these, see if we can do it. Okay, let's take one out of the book here. All right, so we're going to work with problem number 1 on 9.7. Let's start with our initial formula. Okay. So it says Sugarland is fifth largest metropolitan area in the United States. It's in Houston. Okay, the population was in 2012 was 618 million. 6.18 mil. So I'm jotting that down. And the growth rate is at 2.14%. This area is growing at. So it says, first of all, rewrite the formula in terms of this information. So that's what we're going to do in part A. The initial population now is 6.18. E is E. K is R. 0.021914. Want to change that. And T, we don't know. T, time. So this is our new improved formula. Let me turn this a little bit. Okay, that's what they want. And so when they say write the exponential growth function, that's what they're talking about. Write the formula in terms of this problem. Okay, B. Estimate the population in 2018. Well, 2018, 2012, 6 years. You could write this as P6. 6 years from now, the population will be 6.18. E 0.0214 times 6 years from now. And that'll tell us the new population. So let's calculate it. And it's just a matter of using your calculator. Again, to get to E, trying to put this in a good spot without so much glare. To get to E, we need ln-E. Excuse me. We need second ln. That gets us to E, second ln. Okay, and then 0.0214 times 6. Bingo, got it. So about 7 years. It would take 7 years to reach this population, this new population. C. When will the population of this reach 8 million? Okay, we want the population to be 8 million. I'm going to write our formula down. But now we're looking for time. So we're going to use some of our trig, not trig, but our logarithms. ln8 equals ln. Well, before we do that, let's erase this step. Let's divide both sides by 6.18. Let's do that first. We could put this in an ln form, but it's just easier to go ahead and divide it. 8 divided by 6.18. I usually carry that like 4 decimal places or 3 decimal. I'm going to round it off to 5. Okay. These cancel, and I still have my E. I'm trying to get to this exponent, which is way over here. So I'm going to take equals. Be nice to put that in, huh? I'm going to take the natural log of both sides. Now I go ahead and take it. And what does that do? That eliminates the natural log of E. So I have the natural log of 1.295 is just equal to 0.0214 t. Now all I got to do is divide both sides by the 0.0214. And that should give me t. Okay, let's see what happens. ln 1.295 parentheses divide 0.0214. And I get about 12 years. Just say 12. Okay, so that's pretty good. You can go 12.1 or 12 years, pretty close. And the last part of this problem is find the doubling time. Well, doubling time is t is equal to ln2, always ln2, divided by k. T is equal to ln2 divided by 0.0214, our growth rate. K is our growth rate. Okay, and that should give us our answer. it to the 2012. That was our initial. In the year 2046, population should be about 12 million. Oops, here, you can't see that. Sorry. So it's ln2 divided by k, ln2 divided by 0.0214, 32.4 years. You could leave it this way, or the population is going to be double in about 2046. You have to go by the initial year you started. Okay. Your initial population was the year 2012. Okay, well, we have just a couple more things to do. Here's one with interest. Suppose $2,000 is invested, compounded continuously. Growth rate is and it grows to 2,500 in 5 years. What is the interest rate and so on? Okay, so let's see if we can figure this out. Well, let's start with our initial formula. Okay, let's modify that for this problem. So it's going to grow to 2,500. $4.65 equals the initial rate, which was 2,000. E. Don't forget to put the E in there. K is the rate of interest, and we don't know that, times the number of years, which is 5. So this is a little bit harder than the first one, but not too much more. How are we going to figure out K? Well, let's divide first. Let's see what that happens. 25.04.65 divided by 2,000. 1.252. And that's equal to e to the 5k. Then what do you think? Take the natural log of both sides. You see, and that's going to wipe out that. So I'm going to put it right here. Let's put it over here so you can see. I now have ln 1.252 equals 5k. So I'm going to divide both sides by 5, and that should give me the interest rate. .0449 equals k. Or if I want to write that as a percent, it would be 4.49%. There's your interest rate. Let's see if we get it right. This is example 2 in the book, so we can double check. And they rounded it off to 0.045, so 4.5%. Okay, next one. What is the exponential growth function? Well, basically we just used it there. The exponential growth function is PT equals PO, which we know is 2000, E, and we just figured out K, we're rounded off to 0.045 T. And there's our initial growth function. Notice they usually leave T out because, they want to figure it for different years. Like this next problem, it says, what would it be the balance after 10 years? So after 10 years, it's going to be 2000, which is writing this formula down, E, 0.045, but now we're replacing T with 10 years times 10, and we want that. So that'd be 2000. You might as well just work it out. 2000 second ln 0.045 times 10 equals. So after 10 years, it should be 31,360. Oh no, I thought it should be $3,136.62. So let me show you again. 2000 E to 0.045 times 10. And how long will it take it to double? T equals ln2 over, and we use the 0.045, and that'll give us the time to double. Clear this out. Always close the parentheses. Divide by 0.045. Takes about 15.4 years to double. See if that's what they came up with. 15.4 years. I had another sheet of paper here someplace that I can't find. Well, I don't know what I do with it. Well, let's take a look on page 660. Now, on this formula, T equals ln2 over K. If we know the time and we want to find the rate of interest, we can interchange these two. This is your doubling time, or it could be even half-life. We can switch these two. K equals ln2 divided by T. So on a formula like this, these two items diagonally are interchangeable. You can interchange those two. So if you knew the rate of interest, and you want to know how long it's going to take to double, if you know how long it takes to double and you're trying to figure out what's the rate at which it's doubling, just take the time and divide it, ln2 divided by the time, and it'll save you quite a bit of work. This is kind of on 662, they kind of show this. 663 is an interesting problem. You can go through it and work it. I'm not going to work it right now. So The other thing I want to show you is 664. And this is the last one. Let me try problem A, number 3. You have a country, you have a growth rate, and you have a doubling time. Abbreviated. And we'll probably use these formulas here. Okay, so let's go with the US. And they gave us the doubling time is 77. And they want to know what's the growth rate. Okay, all we got to do is use this formula right here. K equals ln2 divided by double time, 77. It's just that easy. ln2 divided by 77. That should give us the growth rate 0.009. Or if you want to write it as a percent, 0.9%. And there's your doubling time. Okay, look at C, Uganda. Here they give us the growth rate, but they didn't give us the doubling time. Well, that's easy enough. Time is equal to ln2 divided by the growth rate. Now, remember, this is a percent. This has to be a decimal always. So we do have to change that to a decimal. ln2 divided by 0.0332. 20.87 years, or 20.9 years. See? So that's all you're doing. You're either using K equals ln 2 over T, or T equals ln 2 over K. Divide E, remember you hit second ln. That gets you to E. Okay, so that's